Okay, I just thought maybe we would try a little bit different video with a slightly different mood, some better lighting, maybe a little music. It's kind of an apology video, and I really feel bad. That's a lot of horse crap. I just had to dim the lights down and kind of change the display so that you could actually see what's going on with these transistors. A viewer had commented on one of the last videos requesting a little bit of information, and I was a little hesitant to give it because I ran into a little boner, and it involves the transistors. And I guess the best way to put it is the 2N quad 2As, while they are an equivalent replacement, and they are listed as an equivalent in places like flippers.com, a couple other sites out there that have essentially the same information. So this is particular to Seeberg. There's obviously other brands and models, makes that are covered in these videos. However, in our case, we're looking at a Seeberg amplifier, so obviously this pertains to Seeberg. And they list many of the equivalent parts that you would replace the old components with, including the preamp transistors, the 309686, which again is the Seeberg number made by Motorola, but not, that number is not what Motorola calls it clearly. So these transistors will work in circuit, but they are not delivering the same amount of punch with the given input signal. So if that's a little confusing, and it should be, let's go ahead and actually take a look at the three different transistors now involved in this little episode of this saga that is repairing this Seeberg. The very first transistor is going to be that original, the Motorola transistor that Seeberg put in their preamp, and that's the one that has been replaced now. We have 10 of those, and we had some distortion. And what I've done here is, I'll just go through the setup very quickly. We are running a 1 kilohertz signal through a single stage amplifier, and that single stage amplifier has the ability to allow us to turn up and down the gain on the transistor. So that allows us to take a bunch of these transistors, whack them into a circuit that's actually causing them to show their amplification characteristics, and we can adjust them so that they're pretty much at the range that they like to be in, and we're able to measure that gain value with the same input. So if we wanted to measure 10 of these, we would essentially take one that was showing excellent gain characteristics, and then we would want to match 9 more just like it with the same input level, and we would want to see the same characteristics on each one of those. I'm going to take this pointer, which is actually a magic Sharpie, and show you how we're kind of set up here. So with our circuit, we have our first channel. The probe attached to our first channel is looking specifically at our input signal, which you can see right now is kind of running around 160 millivolts, or excuse me, 200 it's a little low right now. That's our peak-to-peak voltage. So the channel 2 probe is actually hooked up to the output on our amplifier. So by measuring the input versus the output, we can kind of see the amount of gain that we're getting out of this. Let me go ahead and whack this original Seeberg transistor into circuit, and we'll see what is happening. It's not quite in yet. Here we go. So it's bouncing around a little bit. You see our input signal's kind of stabilizing. We're right at about 280 millivolts, peak-to-peak voltage. And you can see that our output signal, and this has already been adjusted, by the way. Our waveform has already been peaked out. I was trying to save a little time. We're showing it likes to sit right around about 5.6 under stable conditions. Once that warms up a little bit, it'll probably do that. But you can see it is bouncing a little bit, and this is the original Seeberg. But we have a nice stable waveform, and if we kind of took that right around 270-ish millivolts that we're probably pumping into the circuit, and we subtract we subtract that from our output signal, which I kind of had it right around 5.6 volts, you would see that we have a gain of about 5.33 volts. So that's more than adequate, and that's excellent gain characteristics. And if we had 10 more of those, boy, we'd have a heck of a good sounding system, because we'd have all original Seeberg transistors. We don't unfortunately have that. What we have are the replacements that I had, which were 2N4401s, and then the transistors that I ordered, which were considered the equivalent Seeberg part of 2N quad 2 or 2N2222A. So I just like to call them quad 2s at this point, because it's too many 2s in a row. So the quad 2s are the recommended transistor, and let's go ahead and see what one of those looks like in circuit. Now we're in circuit, and look at that. Now that is the same input level. So our input signal has not changed at all, and we're still at about, it's 280 millivolts right there. And we see that our peak-to-peak voltage is now only 3.36 volts. Okay, well, it's a good thing we have a gain control. We can adjust that up, right? Sure, let's go ahead and adjust it up and see what happens. Well, that's not good. The bottom of our waveform is now distorted. So what would that translate to in our amplifier? Well, it's going to translate to some distortion, isn't it? Kind of hitting a wall there. So what would we have to do in order to bring that up? Well, if we were testing these transistors under normal conditions, what we would do is we would run our amplitude up. And I know, because I've already been playing around with this, that if I run my amplitude on my input signal up to, sure I remember, I want to say it's about 200 and, get rid of it now, maybe? That's a little. It's right around 520 millivolts, maybe. Which left us with a little bit of headroom, I believe. If I can get this thing to adjust. I have a WaveTech 270 signal generator, and every day that goes by I'm a little less impressed with it, as it becomes harder to operate. So, too far. About 520 millivolts input. And let's go ahead and adjust our waveform. We'll adjust our gain pot, and let's say a little bit more we can probably squeeze out of it before our waveform distorts. And about 6.48 volts. That's probably about the best we're going to be able to conditionally do. So if we subtract that from our input value, we're getting somewhere around, I don't know, 5.96 volts, which is actually more gain than what our original Seeberg transistor was able to swing. But that won't really help us in this circuit, because we are going to be getting a signal from a phonograph section. So let's pause right there and discuss that briefly. How you use this amplifier. In other words, I'm looking at this segment as, how did you come to this page? Did you come to this page because you are rebuilding a Seeberg jukebox? Or did you come to this page because you were using a Seeberg jukebox in some type of a system that you're putting together, maybe for a listening room, and that's all you have is the amplifier, and you're looking for information on how to make it sound good? Well, if you are rebuilding the jukebox, you are going to be kind of constrained. You're going to need to use that input signal from the phonograph section. Now, there's another place to pause. I don't own one of these jukeboxes. I've never stuck my head inside one of them. I'm an amplifier technician. I work on amplifiers, not on jukeboxes. So I can only use the information that I have in front of me, or what I get from the customer, based on what kind of a signal they're going to put into this. Now, he is putting this into a jukebox, and he is going to be using the signal from the phonograph. So what I do know about Seebergs, and I do have manuals, which, by the way, even Seeberg manuals do not tell me that what this manual that I have covers the SS160, which this amplifier comes in, there's no phonograph information in it. None. I mean, very little. The mechanical setup is there, not the signal levels. So what I do know from my observations and from what I've gathered off of the internet, that the pickup is most likely one manufactured by Pickering. Probably a Pickering 340D. But I can't verify any of this until I actually see that jukebox, which is going to happen tomorrow, by the way. The information that I can find about the Pickering tells me that the signal that will be coming from the phonograph arm via magnetic cartridge is going to be somewhere between 3 and 6 millivolts. That's a very, very small signal. So this original Seeburg transistor is definitely going to do a lot better job working in that range with that smaller input signal. But unless we can move that signal up, unless we can gain some amplitude on that signal before we go into our amplifier, then one of these 2N quad 2s is not going to do us very much good. Even though it does exhibit some higher signal gain, it's at a higher range where it's above that floor for our small signal that's coming in. So in other words, it's going to amplify, but how good of a job is it really going to do? Not very good of a job. So we're going to be kind of stuck with that same input level, whatever it may be, which I will find out and verify tomorrow. So I guess what we're trying to get at is if you compare the two transistors together, then the 2N quad 2 is going to have higher gain in specific ranges as opposed to the original Seeburg transistor. So why? What's the difference? Well, back when the Seeburg amplifier was put into service, switch mode power supplies weren't exactly the let's say the market choice for power supplies on said equipment. So in today's day and age, with our market the way most of our audio equipment that's commercially available, with some exceptions, there are still systems out there that have linear power supplies, and they're wonderful. They're very quiet, but they're very expensive, and they can be they can be very wasteful with basically bleed off energy. You got to dissipate that extra wattage somewhere, and that usually goes out in the form of heat through resistors, and it's just very inefficient. The argument being among audiophiles, which I am not one, so I don't want to get into it, please. They sound switchy. The switch mode power supplies sound switchy. They can hear the distortion, and maybe they can. It's not for me to decide. The sound quality that you want from your system is going to be attuned for your ear, not mine. It's not my job to tell you whether something sounds good or bad. My job is just to make it work. So having said that, the switch mode power supplies are able to deliver the same power with a lower voltage because of the frequency at which it's delivered. That's probably the simplest way to put that, and I hope it's not too confusing. So the transistors used back then would have a higher voltage threshold, would have higher voltage thresholds for base collector, emitter, and what have you. Whereas today, to find one electrically similar, we can. The 2N quad 2A is electrically similar when it comes to the threshold voltages, but it's not similar when it comes to the gain characteristics. So we need a transistor that will work like the original Seeburg did, or else we're going to have to modify that signal somehow, some way, before we bring it into the amplifier, which can cause other types of distortion issues, and now we have to talk about power supplies and all kinds of other stuff. So unless we can find a basically unicorn transistor, one that magically appears that says, hey, I'm going to do exactly what this original Seeburg part does, and we're going to be cheaper enough so that we can buy a whole lot of them and to be able to match 10 of those, we're kind of, I think the term is pissing up a rope. It's going to take a long time to find something like that. Unless somebody has one and you have the information, by all means, please comment in the section. So essentially we're kind of, at this point, stuck with what we got. Now, just to throw a little bit more information in there, let's take a look at the 2N4401. Now, this big stuff through hole older amplifier stuff, it's a little new to me. The theory isn't, but the actual repair and restoration of them is. And what I worked on before was mainly everything from tablets and cell phones and yada yada, laptops to regular, which you would call commercially available audio amplifiers, such for your your car's audio system. And an amplifier is kind of an amplifier is kind of an amplifier. Having said that, most of that had mostly surface component parts. And then when it came to transistors, there's the common one that you would find a lot is the 2N4401, which is low noise and a decent quality amplifier transistor, signal transistor. So I have, I believe the term is a proverbial buttload. There's other words that start with F and end with ton. I would go with that one, but I want to be sensitive to the YouTube audience. So these are really still kind of common, and it's one of the more common through-hole type transistors in a TO92 package that you would find in some of these newer amplifiers, and you can go up and but the electrical characteristics are there, but the lower gain is there, because a lot of times you'll find more amplification stages in some of these. So let's just take a look at, now this, what we're looking at right now is the 2N Quad 2. Let's take that out of circuit, and we'll go ahead and we'll put in our 2N4401 and see what that looks like. Well, boy, I'll tell you what, that looks pretty close to that 2N Quad 2, doesn't it? So the difference is that we can actually drive the gain up just a little bit more on this one, just a hair, and we can get slightly better amplification, slightly better gain with the same input level. So I guess when we're looking at the three transistors together, if you wanted to actually rate them, we're not exactly comparing apples to oranges, but it's more like oranges to tangelos, maybe. The best choice for this amplifier, because it was designed for this amplifier, would be the original Seaberg transistor, but we can't get that. It's just not possible. The next best before would have been the 2N Quad 2, because it's been around since, I don't know, like 1962, manufactured by Motorola, and I think then it was Central, or I believe Central Semiconductor manufactured. And then later comes the 2N4401. Well, the 4401 is going to be better. It's going to have a better gain value on it. Electrically, they're going to be, as far as threshold voltages go, it's going to be very similar. And it's probably going to have slightly better noise distortion characteristics. It's going to keep those distortions to a little bit more of a minimum than what the 2N Quad 2A is. Now, again, audio people that swear by their ears, they may have a different opinion on that, and they very could possibly be right. I don't want to get into that argument. What I would say is, electrically, if you're looking at the numbers and the waveforms, generally speaking, the 2N4401 does a little bit better. Now, since our amplifier, I already put those in order to keep testing it, and since that's already been done, I'm not even going to bother. Even though I matched about 14 of these 2N Quad 2s, I'm not going to bother putting them in. I'm just going to leave the 2N4401s in there. I do need to do a little bit more work with the tone section. For some reason, I'm not getting the control. When I move the switch for the bass section, I don't really hear much of a difference. I'm not seeing much of a difference. I think there's a little problem in there, and there's some kind of hiss. Now, I don't know exactly where that hiss is coming from. I would assume it's from my speakers. But I want to hear it in the jukebox. I want to actually get up there, take some measurements, hear it in the jukebox, and we'll see what the customer has to say. If he's happy with the way it sounds, we're probably going to leave it. So I guess the final portion of this is I would compare, if you are using the amplifier in your home-built system, where you've just cobbled something together and put some thought into it, maybe this is what you could find, or it's what you wanted, and you're experimenting around with it. It depends on what you're going to drive that initial signal with. If you are going to be playing this like from, let's say, your cell phone or a dedicated tablet or maybe a CD player or something that has a dedicated signal, more than likely that is going to be a much higher volume signal, and you're going to get better results with very low volume, and you will have to play with that volume coming from that device. That input signal is just going to be different as it comes out, and you'll probably find that as you drive it up into higher values, higher amplitudes from your device, that you will probably get maybe some digital, maybe kind of sounds in there, or maybe some slight distortion. So you're going to want to play with it, back that down just a little bit, and then adjust your gains on your amplifier. Now, once you have that kind of dialed in, and this would apply to both the Seberg jukebox or just using the amplifier through your own system. Once that's kind of dialed in, you're essentially looking at how big is the room that you're going to listen to this jukebox in. The original transistors would clearly be the best way to go. Since they're not available and we can't match them, we need to use the next best thing. The next best thing, in my opinion, would be the 2N4401, but the 2N Quad 2A will work just as well, especially in this environment, which is, if you're trying to fill an entire banquet hall with sound, you'll probably be disappointed, especially with your jukebox, because of the lower signal amplitude from the phonograph. If you're only trying to fill a small to moderate size listening room, these transistors are going to work just fine. You shouldn't have, you shouldn't really be able to tell a noticeable difference. It's going to be the volume that you can adjust it to before it goes into distortion, and the idea here is we want to have the gains and everything adjusted so that as I turn the volume up to full maximum volume on the amp or on the jukebox, the volume control, that we are just about 20% below distortion, where our speakers would go into distortion, because our signal would go into distortion, because we want to be able to have full volume. And then keep in mind that full volume at a, let's say, a 1500 kilohertz signal is that the power is going to change depending on the amplitude or the frequency of that signal. So if we all of a sudden get a bunch of bass in there, you might get some distortion, or we just get a real quick frequency change, to a different. It's going to change the distortion floor or ceiling. So, in a nutshell, if you're using this thing as a collector, and you're using you're putting it in a small to adequate, moderate size room, and you want to fill that room with sound, either of these transistors, the 2N Quad 2 or the 2N4401, they are going to work. They shouldn't change any of the tone. They shouldn't change any of the electrical characteristics. The distortion can be, you'll be adjusting this so you can provide max volume under distortion. And when you're completely set up, the only difference you should be able to recognize between your jukebox with these transistors as opposed to the original is you're not going to have the same volume. The volume is going to be reduced. I can't give you an exact percentage. It's going to it's going to depend on where you're listening to it and how it's going to sound. But if you're okay with that, then this would be definitely an acceptable method of repairing and restoring your jukebox or amplifier. If you're really critical and you really want those original transistors, I would submit you're probably going to wind up paying a lot of money for something that, I'm not really just, it's going to be up to you whether it's worth it. For my pocketbook, it wouldn't be worth it. But maybe for yours, it might be something to look into. And that's really the only way you're going to get that sound, is if you manage to get your hands on some of these original Seberg transistors. And if I find out what the actual transistor was, the 309686, if I can find out what that was, I will post that information immediately. I'll probably make a video about it. But until then, I think we're going to have to just call it quits with the transistors. They're as matched as I can get them right now. They're already in. We're going to play around with the capacitors a little bit in the tone section and see if we've got something slightly amiss there. Check resistor values, and then I need to check some things out with the jukebox, and we'll have another video up soon. So, okay, I hope that straightened everything out. I just wanted to say thank you to everybody who's been watching and everybody who's commented. I really appreciate the feedback, and we will see you in the next video. Thanks for watching.